Okay, so we're going to do a Thevenin problem here and an example. And so I'm going to run through Thevenin one more time just to be sure we know what's going on. This is the circuit I'm going to use. The reason I'm using this circuit is because I'm going to also use superposition to solve Thevenin. Superposition is a little weird, but this problem, or a problem like it, actually is a really nice problem they put on the FE exam, that if you use superposition, it is so easy because it's like 4 or 5 current sources, and each current source has a series resistor with it, and then they all go into parallel, and then there's like 2 resistors down on the end. And the way superposition works, you take all the sources out, open circuit the current sources, short circuit the voltage sources, and you stick one source in at a time, and it's just a little series network every time, and you add them up at the end. Anyway, we're going to do that, but first we're going to go over Thevenin one more time, and it works the same way in AC as it did in DC. The first way is you have all independent. I don't know how to spell independent. And if you have all independent sources, then you solve for any two of VOC, ISC, or RTH. And if you, depending on what you solve for and all that stuff, then VOC equals ISC times RTH. In this case, really and truly, we're talking about ZTH, but we'll keep it with RTH. Maybe we'll try and take it out and not delete our stuff here. Let's see. Let's make these Z's. How about that? And make sure we don't kill our recording. That really ticked me off. Okay, so this is ZTH. Okay, impedance. All right, the second is you have both dependent and independent. In I, in DE, PE, in DE, and T sources. And you have to solve, must solve for VOC and ISC. And use Ohm's law to find ZTH. Then ZTH equals VOC divided by ISC. And then the third method is the electronics method. The problem with electronics, I don't teach electronics in this class anymore, so I'm not teaching this. But just for the heck of it, we'll just touch on it real quick. The third way is all dependent sources. And you insert a small voltage source. And solve for the current through the voltage source. Or the second way is you insert a small current source. And you solve for the voltage across the current source. Okay, so 3 ways to solve for Thevenin, 3 different types of circuits. So you need to make sure that when you go to electronics that everything's dependent, and you're going to have to do that. So let's get back to this problem. Again, I'm going to solve it first using superposition. And it's, well, I won't say it's straightforward, but it's not that big of a problem. So here we go. Here's our circuit. We've got the 4 angle 0 degree source at the top. And then we have the 1 ohm resistor. And all this comes down, and you have another 1 ohm resistor. You have the 6 angle 0 degree amp source. By the way, I made me a little writing platform so I don't keep touching all the buttons and everything, and that's why I'm writing so much nicer than I used to write. So just saying, ingenuity at work. This is minus J1 ohm capacitor. Then I have the inductor, J2 ohm inductor. I have the 2 ohm resistor. Oh, well, that's a buddy of mine wanting to know if I want to eat pheasant, but not tonight. Anyway, back to the story here. There's my circuit, and I want to find VO in this direction using Thevenin. All right, so the first thing Thevenin requires me to do is to pull out that 2 ohm resistor and stick that thing in my back pocket. So here's my back pocket, and there's my 2 ohm resistor, and there's my circuit. Okay. So I'm ready to solve for this. And if you're a loop equation person, you're going to go 3 loop equations. You have all the values for the loop equations, and you can just use Ohm's law to solve for VO. That's pretty easy. If you're a node person, then what you would do would be you would solve, I would anyway, and it's up to you. You only have 3 essential nodes. And I would go ahead and solve for this node, let's say VD, and that value of VD would be VOC. Now, this is one of the few times that it behooves you to solve 4 node equations because you come up with VOC when you solve that 4th one, VD. Now, again, what do you see? How do you want to do it? If you're a loop person, well, you know, I1, I2, I3, three equations, three unknowns, but it doesn't really help you out because now you got to see, did I see that I need to find the voltage across each one of those 1 ohm resistors and the J2 ohm impedance. So it didn't really help me much. So I'm going to use superposition to solve this thing. And basically superposition is you remove all the sources. Now, the caveat is this works only with independent sources. It does not work with circuits that have dependent sources in it. So don't start using this. It only works, caveat, XXX, star, star, star. It only works with independent sources. Okay? It only works with independent sources. It does not work with anything else. So remove the sources and you short circuit the voltage sources. You open circuit the current sources. And you solve for, put in input, I guess, put in one source at a time. And solve for the value you want each time. I guess I should put for each source. Okay, so let's try this out. So here we go. Here's our circuit. I'm just going to leave, and I'm going to go to, I need a different color. Red's not my favorite. Wherever it is, there we are. So we're going to go back to black. Okay, so here we go. So we have the 4 angle 0 degree source. We have the 1 ohm resistor. We have the 1 ohm resistor. We have the minus J1 ohm capacitor. We have the open circuited 6 angle 0 source. We have the J2 ohm inductor. And we have the open circuited 4 angle 0 degree source. And we are looking for the voltage across here, VOC. And I'm going to call it 1. And what does that equal? Okay, so let's look at this. This is a node. And this right here is a node. And here's a node. And here's a node. And here's a node. Okay, so what does that look like? So I'm going to kind of redraw it a little bit differently, and we'll go from there. You have this current source, and you have the 1 ohm resistor, and you have the minus J1 ohm capacitor, and here's the 1 ohm resistor, and here's the inductor, This is the plus J2 ohm inductor, and I'm looking for the voltage VOC1. Well, that looks pretty easy. Mainly because voltage can't flow in an open circuit, or current can't flow in an open circuit, so you can't find voltage across these two right here because they're dangling out in space, saying, hey, look at me, don't use me. And so VOC is actually across the 1 ohm resistor there. And look, the current source, the current is actually going into the plus sign of the voltage drop. So here we go. This is going to be 4 angle 0 degrees times 1 ohm equals 4 angle 0 degree volts. Two real numbers, real result. Okay, so that's VOC1. So now I need to do the next current source. I'm going to put that other 4 angle 0 degree current source in here. And here we go with our circuit. Let's see. Our next circuit looks like this. We have the open circuit. We have the capacitor minus J1 ohm capacitor. We have the 1 ohm resistor. We have the open circuited current source. We have the 1 ohm resistor. I need to slow down a little bit and I can go write a little nicer. But okay. Then we have the 4 angle 0 degree current source. We have the inductor, J2 ohm inductor. And alright, there we go. So that's our circuit. Oh gosh, let's see. This is a node, and again, AB. I'm looking for VOC. And here's a node, and that's one big node right there. This is one big node right there. Not really a node because that's an open circuit right here. So not really a node. So let's redraw it into something I might want to see one day. And so here we go. 4 angle 0 degrees. I have the inductor, J2 ohm inductor. I have the capacitor minus J1 ohm capacitor. I don't need to go up and capture this piece. That's just nothing. There's my node. I shrunk it back to one little dot. I have the two 1 ohm resistors. Here's my A node. I come over here. Here's my B node. And I'm looking for VOC 2. Once again, these two 1 ohm resistors, no voltage drop because current can't flow in an open circuit. And so VOC is across that J2 ohm impedance right there. And notice that the current source goes this way, but Ohm's law says I need the current to go into the plus sign of the voltage drop. So that's going to be minus 4 angle 0 degrees times J2 ohms. And this is going to be minus J8 volts is VOC2. Questions about that? I just hit the current source with a negative sign. It pops, it goes backwards and multiply it by the J2 ohm inductor and get minus J8. So there is that one. So now I need to put in that 6 amp source. So here we go. I've got the open circuited 4 and the 1 ohm resistor and the 1 ohm resistor. And then here is my 6 angle 0 degree amp source. I'm looking for VOC. I have this open circuit, comes around, hits the capacitor, minus J1 ohm capacitor. I have the current source that's missing here. I have the inductor right here, J2 ohms, and I'm going all the way out here, and I want to find VOC3. Okay, so let's see, VOC3. How is this going to look? So I have one big node here. I have a node here. This capacitor is not hooked to the circuit, so it's gone. Both ends, this end over here is not connected to the circuit, so it's out of there. This is one big node I can shrink down. And so what I have then is, I'm going to draw it a little differently. I'm going to flip those two 1 ohms on the other side of that source. So this is what I have. Forgot the inductor here. I'm looking for VOC3, and this is 6 angle 0 degree amps. So basically all I did was turn the thing, I rotated it counterclockwise 90 degrees, threw the resistors onto the right side of the source, and found VOC3. And this is pretty easy. Once again, dangling in space, current can't flow, so no voltage drop. VOC then becomes across the two 1 ohm resistors, and that is going to be 6 angle 0 degree amps times 2 ohms. 1 plus 1 is 2, and this is going to be 12 angle 0 degree volts. Okay, so if I look at all this stuff, then VOC equals VOC1 plus VOC2 plus VOC3, which equaled 4 angle 0 degree volts minus J8 volts plus 12 angle 0 degree volts, and 4 plus 12 equals 16 minus J8 volts. So that's VOC. Now, I'm going to go back real quick and just show you what you could do with if you decided to write something else or do something else with the circuit. So here we go. I'm going to do it if you were a loop person. I'm not going to do the nodes, too much work. You guys can do the nodes. So this is 4 angle 0 degree amps. I have the 1 ohm resistor. I have the 1 ohm resistor. I have the 6 angle 0 degree amp source right there. We're looking for VOC out there. Okay, here's my capacitor. Here's my inductor. Okay, and then I need to close this up here. Okay, and we're looking for VOC. All right, let's see if I get the same answer. Hopefully I do. All right, here we go. I'm not going to use per se, I'm not going to use loop equations, but I'm going to use the current sources that are there. So here we go. I'm going to say that this 6 amp current source flows right there. So this voltage drop, notice that this voltage drop and this voltage drop are in the same direction. I could redraw it and push that piece of the puzzle up. Maybe I should, but anyway. I'm not. So this is going to be V1. I'm going to solve for this V1. And V1 equals, notice that the 6 amp source is in the same direction as that voltage drop. This is going to be 6 angle 0 degree amps times 1 ohm, and that gives me 6 angle 0 degree volts. Maybe I should redraw it. Let's just look at this in a different light. How about that? So here we go. Here's our current source, 4 angle 0 degrees. Comes over here. Hits a 1 ohm resistor that way, hits a 1 ohm resistor this way. Here's the 6 angle 0 degree source. And then here's my capacitor. And this is minus J1 ohm. Need a little more room here. And then I have a J2 ohm inductor. And then I have this 4 angle 0 degree amp source. So really and truly what I did, I said, okay, here we go. V1 is in this direction, and this current source is coming up to here. Okay, so V1 equals 6 angle 0 degrees times 1 ohm, which equals 6 angle 0 degree volts. Everybody see that? All I did was just rotate that source. I just rotated this part of the circuit right here up to here. Okay, that's all I did. So pretty, well, maybe not easy to see, I don't know. Anyway, now then, what I have is I have this current source going here, 4 angle 0, and I have the 6 angle 0 coming in here. So the 4 plus the 6 then is going to give me a voltage drop across here. V2 is going to be 4 angle 0 degrees plus 6 angle 0 degrees current times 1 ohm, and this is going to be 10 angle 0 degree volts. Okay. Notice that so far all my voltage sources are in the same direction as VOC. Remember, voltage in parallel is the same. If you want to look at this, you could also say that the voltage across this is 6 plus 10 is 16 angle 0 degree volts, if that's what you want to do. Voltage in parallel is the same, V1 plus V2, 16 angle 0. So now then what I need to do, I need to find this voltage. Well, the only thing going in this direction is this 4 amp source right there, but since I need Ohm's law to work, I need that. And so that's going to be V3. V3 equals 4 angle 0 degrees. Don't forget the minus sign because current's going in the opposite direction, times J2 ohms. And that gives me, where's my thing? There it is, hard to see. There we go. So then this equals minus J8 volts. So then VOC equals 16 minus J8 volts. Same thing I got for the other one. Now what I need to do is go find RTH. So here we go. We're going to find RTH. So we found VOC two ways. We're going to find RTH. And I'm not going to find VOC or ISC. Excuse me, this is ZTH. Sorry, not RTH. Still stuck in DC, I guess. All right, so Thevenin says open circuit the current sources. Here's my 1 ohm resistor. Here's a 1 ohm resistor. Here is my J2 ohm inductor. Here's my capacitor. And then I have this current source right here that's open circuited. And I'm looking for VOC, or ZTH, sorry, ZTH. So I'm looking for ZTH. Well, once again, the capacitor, the opposite end of this capacitor is not hooked to anything, so it's gone. So if I look at going from A to B, just saying, if I go from A to B, if I say this is A and this is B, I'm going to go from A to B. And there's only one path, so then ZTH then equals 1 ohm plus 1 ohm plus J2 ohms, which equals 2 plus J2 ohms. All right, I'm done. So now all I got to do is find VO. And I go back to my Thevenin to find VO. And should be pretty straightforward. I have VOC, which was 16 minus J8 volts. I had the RTH, or ZTH, which is 2 plus J2 ohms. Now then I stick my 2 ohm resistor back in here and use voltage divider to solve for VO. And this is going to be 16 minus J8 volts times the one I want, which is 2 ohms, divided by the sum of the impedance. And I get this to be something along the lines of, what, 4.6 minus J8.2, if I'm not mistaken. Yes. I get, 4.8 minus J 6.4 volts. Or if you prefer the rectangular format, that's going to be 8 at an angle of minus 53.13 degree volts. Thevenin's theorem, Thevenin example. Next week I'll post some homework for AC, probably node and mesh, or node and mesh will be, just write the equations, and then probably a couple of Thevenin problems, one with independent sources only, and then one with independent and dependent sources, and then we're going to move on to power. We got a lot of ground to cover that we haven't been covering, so we'll post this and get you going. Don't forget, 7 o'clock is the study session tonight. We're going to use Zoom and see how that works.